Hello everyone, and welcome back to a new video in programming the finite element method using MATLAB. In this video, we are going to talk about the logic behind dealing with releases in fembars and how we're going to implement that by adding a fembar spring between a node and another node. So this means we are going to generate slave nodes and apply those fembar springs to them. Now, before I start, I want to give, first of all, the quick information that this is part of the FEM video series, which is linked in the top right, and it's also part of its standalone programming video series, also linked on the top right. And as per usual, my dear channel members, whom I would like to extend my sincere thanks to, always have access to my source code. But if you're not a channel member, then don't worry, because you can write along and you would have the exact same code as mine, because every single line of code that I write will be shown in front of you. So let's see how we can do those releases, and with that being said, sit back, relax, and enjoy the show. Now, we're not going to do line offsets here. This was a wink to my Strado software, because in the Strado code there is a portion for the line offsets. Now here, let's deal with the releases, okay? So, first of all, let me explain to you again how I'm planning to do the releases. Let's say I have a bar or a beam, and this beam has three STR nodes on it. Its starting STR node, its ending STR node, and an STR node that is in the middle for reasons that are unknown, for example, because of intersection with another line, or because the user just added an STR node there. So there are three STR nodes. We already have declared, or we already have created three fem nodes, because remember, there is a model view and there is also the fem view behind the scenes. So for those three STR nodes and the bar, we already created three fem nodes, and we are going to create two fembar beams. But that's not everything, because the beam could be released in the beginning, or could be released in the end, or could be released in both beginning and end. Let's take the general case where the beam is released in the beginning and in the end. If a beam is released in the beginning and in the end, then I would have to model the release by using a spring. So, in the end, I would add a spring, and in the beginning, I would add a spring. But wait a minute. If I want to add a spring, I need two fem nodes. So suddenly, besides the original starting fem node and the original ending fem node, I must add a slave fem node in the beginning and a slave fem node in the end, and connect the original beginning fem node with the slave beginning fem node with a spring, and connect the original ending fem node with a slave ending fem node by a spring. So this is something I need to do, and I need to check. And that's the reason why we are going to do some checking shenanigans, where if the code basically will check if there is a release in the beginning, it will add an extra slave fem node. And if the beam is released in the end, it will also add an extra slave fem node, and then later connect them by springs. So that's our objective for today. Let's dive into it programmatically. So here, we need to check, first of all, if the line has a release. So here, I'm gonna state, well, let's state the obvious here. If the line, wait, is it called line? What's it called? Yeah, it's called line. So if the line dot release exists. Now, how do I check for that? I check for that by saying is object line dot release. So does there exist an object in the release of the line? Now I need to check if that's exactly how I called it, because it's been ages. Now for you, it might be just 2 weeks, I don't know. But for me, it's ages because I'm programming this. So I go to properties, and indeed, I called it release. So I can check is object release, which I do here. Now, if there is a release, I need to know if it's in the beginning or in the end. Now, first of all, let me fish it out. So let me say release here equals line dot release. because this shortens my notation. Otherwise, I would always have to say line.release, which gets tedious. I need to ask a question or give a boolean, is start released? That's a question. Now, is start released depends on the spring stiffness that has been applied. So how do I know that? Well, let's say first of all, start is released, that's a false. And let's make the if statement that causes start release to be true. Now, I know you programming geeks, you could be able to just do it in one sentence by copying the condition and pasting it here, and that would be perfectly fine. It would be even more, it would be a boss move, basically, programming. However, I told you before, I'm trying to strike a balance between our simplicity and programming efficiency. So I know that you are more efficient than me, maybe, you have more experience than me, you are more specialized than me, so you could just write the condition here and that's it. But no, I want to keep it simple. So if, what are the conditions that would cause me to notice that the start is released? Well, first of all, the spring must be anything but rigid. So I need to go to the release and make sure I have written this correctly. In the release, yeah, those are the rigids. Okay, so here I'm gonna do the check. If release dot, I'm going back and forth to releases because I want to know exactly what the, okay, KUX start, KUXN, those are the things, right? Okay, release dot KUX start is not equal to release or str release dot, wait, it's KU, right? KU rigid. So if it is not rigid, then there is a release. That's one of the conditions, because there are others. Also, I mean, only one condition is enough for me to place a release. So if the KUX is released, this means that we need to apply a release. If the KUY at the start is released, it means we need to apply a release. If the KUZ at the start is released, same thing. If the KRX, I think it's small, is released, but we need to change to R, then that is a release. And we need to do this for every single degree of freedom. So let me just take this copy and paste it multiple times. Those are the conditions that would signalize that, hey, there is a release at the start. If any one of those is not equal to the rigid, then there is a release. Here, KUX start, KUY, KUZ, KRX, KRY, and KRZ. If that's the case, then is start released is true. For you programming geeks, I know what you're thinking. I could have copied this and pasted it here and would have the exact same effect. And you are right, but I want to keep it a little bit simple. Simplicity, even at the cost of efficiency. Now this is, of course, for the start. Now I need to do the same thing for the end, because I also need to check if the end is released. So is end released? Now here the same conditions apply, but here instead of start, I need to switch everything here to end. So let me do this very quickly. Now we checked if the start is released and if the end is released. So now we need to get to the generation of the fem bars and the fem nodes. So here, after this comment, I'm going to ask the question, if is start released? So if the start of the beam is released, then stuff will happen. Also, if the end, is end released, then other stuff will happen. There is no else if statement between them because they both can happen and they are both independent from each other. There is no else between them. So let's see what happens if the start is released. If the start is released, I need to create a new fem node besides the starting fem node. So besides it, right? So in the direction of the beam. That's very hard. So I want to shift the fem node in the direction. Okay, let's declare Vx. And this equals line.vx. This is the direction of the beam. Now I want to shift it a very small value. Now Vx has a length of 1 unit because it's a unit vector. So I could take Vx and just multiply it by epsilon. But that's a problem because I could trigger the protection system. Because I'm going to add a fem node, I'm afraid I would trigger the protection system if the fem node is too close to its partner. Let's go for it. So epsilon, it's not epsilon, it's I think controller.epsilon, right? str controller. Wait, is it a constant or I need to deal with the constants here. It's not constant, so I need to declare object. Object.epsilon and times 10. Okay, so we generated a Vx, which is going to be the thing that we will use to push another fem node. So here I'm going to go and say first fem node, and this is basically the, what did I call it? Sorted fem nodes? Fem nodes sorted, yes. Fem nodes sorted, and that's the first value. So this is the first fem node, okay? Now, since we have a release in the beginning, I need to take the first fem node and I need to create another fem node that is a small distance away from the first fem node, as I have explained before. So here, I'm going to add me something called a fem node, and I will basically ask the controller to add me a fem node, and this is going to equal the first node for first fem node dot x plus Vx of 1. So I'm going to increment it a little bit in the x direction, and first fem node dot y plus a little bit in the direction of y, and first fem node of z plus a little bit in the direction of the z. Yeah, I think that should be working. So that's our new fem node, okay? Now this fem node is going to be the slave to the first fem node. So we need to declare some stuff about it. Now, first of all, this new fem node still has the corresponding node ID, or corresponding str node. So corresponding str node, this equals the first node dot corresponding str node. So suddenly there are two fem nodes that have the same corresponding str node, because they actually are kind of merged into that str node. I will explain the consequences of this later. So fem corresponding str node equals first node corresponding str node. That's true. And of course, the new fem node here is master node. That's no. It's not a master node. Fem node dot is slave node, and that's true. It's a slave node. Fem node dot master fem node. This is something true, and it knows itself. It knows the first fem node. The first fem node is its master. Now, I think it's not a support node, so fem node dot is support node. That's a no. Now the question is, should I let the first node know that this is its slave? Let me put here a comment and say first fem node dot slave fem node. That's my fem node, okay? Let me keep this for now, because I'm afraid that I might have a slave fem node already, and this would break the entire system. So I will keep it for now. Okay, so we added the slave node. Now here, since I added the slave node, things must change in our fem nodes list sorted. Why? Because we added a new first fem node. So I will say now that fem nodes sorted is going to equal the new fem node, and after it, the fem node sorted. So I added the new fem node in the beginning. Now, since the original fem nodes, the master ones, have shifted, I must keep track if the master nodes have shifted. I actually must keep track of any change in the master nodes. So here in the beginning, before I check any releases, I would go here and say start index is 1 and end index is the length of the fem nodes sorted. So what I'm doing is I'm keeping track of the real fem nodes that were added because of the str nodes, because I need to use them later to create my fem beams. So now, since I added a fem, things have changed. The start index of the real fem nodes has been shifted by 1 because I added one node in the beginning. And also, the end index of the real fem nodes has been shifted by 1 because I added a fem node. Okay, so I keep track of those. Now I need to add a fem bar. So I say here, fem bar spring. This equals the controller. This is the spring that represents the release. I'll tell the controller to add an object. And by the way, my videos are getting a little bit intense, so you may need to pause and rewind sometimes. And now I need to give the nodes, right? So from the first node to the fem node. This is my fem bar spring, and here fembar.kux, I guess. Wait, let me just check. Kux equals the release.kux start, And you get the drill. I need to declare all the spring stiffnesses. So krz also fem bar dot corresponding strline. This equals the line. Okay. I would have to do the same thing. I would say line or vx. Should I copy paste? No. Line.vx. Now I will say basically that my vx this time, not plus, it's going to be minus. I want to keep them inside the beam. Multiplied by -1, multiplied by 10, multiplied by the epsilon, or the object.epsilon. So instead of 10 epsilon, I multiplied by -10 epsilon. Now I think I should copy and paste the same things, right? Here I called it first fem node. Now here this is the last fem node. So last fem node. This is gonna be fem nodes sorted, and I need to select the end. So I'm gonna here say end. This works in MATLAB. Usually, let me try this. A equals 1, 2, 3. A of end is 3. Okay, so this should be working. Fem node sorted should now give me the last fem node. Okay, now we need to create a new fem node. So fem node, this is the new one. This equals object controller.add fem node. Here, I need to take the last fem node.x and add to it vx of 1. Of course, it's negative. And last fem node.y and add to it vx, the y component, and last fem node.z and add to it vx, the z component. So I have a new fem node. I copy this entire because I think this doesn't change. And paste here. So corresponding, I cannot simply copy and paste. There will be a ton of errors. Corresponding str node is going to be the last. Wait, there is no first node. It's called first fem node, right? Why am I writing first node? From where did I get that? Oh, that's bad. Let me just copy that. This is a bug. Let me copy this and check. First node? No, first fem node. And here, first node? No, that's first fem node. And here, first node? No, that is going to be last fem node. So last fem node corresponding. It is not a master node. It is a slave node. Its master fem node is the last fem node, and it's not a supporting node. Now maybe I should last fem node slave equals this fem node. Maybe. I am not sure. But okay, fine. Now we need to define us a bar. So I can, oh wait. So what kind of error today? What's wrong with me? Let me just paste this because I called it fem bar spring and then I call it fem bar y. That's a mistake. Okay, now I can copy this entire thing and paste it here, but be very careful that I need to change things. So here, fem bar spring, that's the last one, equals object.add fem bar spring, and here it's going to be between the fem node and the last node. Then the fem bar spring kux is going to release kux end because you are in the end release, not the start release. Do I need to change the start and end indices? I don't think so, because I didn't add it. Wait, that's a mistake. I didn't add it. I must add it. Yeah, I must add it. Here, I must add the new node. So I will go here and say fem nodes sorted, that's its name, is going to equal the old fem nodes sorted. I'm going to add to its end the new fem node. Now I added a new fem node, but this doesn't change the index of the start node and the index of the end node because this is a shadow fem node, not the real one. Okay, so I think we have generated the bars that represent the releases. So yeah, I think we have reached another milestone. And next time we'll talk about the fem bar beams. That's everything I wanted to talk about today. I hope you enjoyed. And with that being said, I want to give a huge released-sized shout out to my dear channel members in the contributor level and the helper level whose names are going to be shown on the screen. I want to thank them from the bottom of my heart, as their support of the channel is priceless to me and enables me to provide you with videos hopefully on time and with a certain quality I try to achieve, and for that I am forever thankful. In the end, I hope that you enjoyed the video and you found it beneficial. If you have enjoyed the video, then please consider liking, sharing, subscribing, commenting, and so on. Especially subscribing, because it helps increase the reach of my channel. As per usual, this is the Civil Engineering Essentials channel, and we'll catch you in the next video. Bye bye.